Hello everyone, welcome back to another video. So today we are talking about the gradient once again. So this little number in front of our x. And I loosely defined this idea in the last video, but I'm purposely kind of trying to pull back from that until the next one where I'll talk about really what the gradient's telling us in depth. But we mainly defined this as the slope. And it pretty much, this number gave us a way to relate y and x in our linear equation. So this number basically told us that, all right, well, in previous cases, say y would be 2 lots of x. And this number told us pretty much how y changes with x and sort of to what degree this changes with x, whether it was in this example here where y was always half of x, whether y was 4 lots of x or 3 lots of x, etc. Now, we spoke in those videos only about a gradient, which was a positive value. Now, today we are going to look at what happens when we make this number negative. And this is a whole other branch of linear relationship. So once again, I'm going to approach this in the easiest possible way, and that is to write a table of values showing what happens between my x and y for different values. And once again, I'm going to start at -2, -1, 0, 1, and 2. And I'm going to approach this in the same type of way as I've done before. So y is always going to be -2 lots of whatever x is. So when x is, say, -2, well, y is -2 lots of -2, or -2 times -2. Now, because we have a double negative there, these two numbers will multiply to give us a positive. Same in the -1 case. 2 times -1 gives us +2. -2 times 0 gives us 0. -2 times 1 gives us -2. And -2 times 2 gives us -4. So I'm going to throw in another xy plane here. And we are going to actually plot this on our xy graph. And we're going to look at what actually happens here. So when x is -2, we get the y here is actually 4. So compared to the last examples from our last couple of videos, this actually starts up here. If my pen would stop glitching. Cool, there we go. At -1, at x is -1, y equals 2. So I'm going to plot this point here. We have the point 0, 0 again. We have the point 1, -2. 1 on the x-axis, -2 on the y-axis. And we have the point 2 and -4 here. Okay, so once again, as we expected, and based on how the table looks, each of these variables, x and y, are both changing in a linear fashion. They're moving with uniform intervals. X once again going up by 1, y going up by going down by 2. That is our first kind of difference. Well, y goes from 4, then it goes down to 2, then it goes down to 0, down to -2, down to -4. So what we can see here, even just by looking at our table, in this case, how this differs to the positive gradient number here, this time, as x goes up, y goes down. If you remember from the last video, we looked at, in all of those cases, y increased with x. As x kind of went up in the positive direction, y went up in the positive direction. But here, as x goes up, y goes down. So connecting a line through each of these points, well, we get, I'll write this equation in, y equals -2. I'm going to have a different type of line happening. So here, if we look at our graph from left to right. So reading from this side across. A good analogy I give is, we read books, at least in Australia where I'm from left to right. So we read graphs in the same way. Now, looking from left to right here, as my x goes up, my y goes down. Let's compare this to this one. Here we had as our x goes up, as our x went up, our y went up as well. Here it's a little bit different. And the only thing we've changed in the linear equation is this negative. So this negative is responsible for making the y decrease as x increases. And we call this a negative gradient. So we still have a slope and we still have a relationship that, well, when x here goes, let's do another color here. When x goes up by 1, y goes down by 2. So that's the role of this 2 here. But we have to look at the direction in which in which y is going. Now, y is going 2 units in the negative y direction. It's going down here. So we can say that this slope, this relationship between our variables, x and y, is a negative relationship. There is a negative slope because as x goes up by 1, y goes down by 2. So it goes negative 2 units since it is going down on its axis instead of up. So we can make two conclusions here. Well, we can say that, so first of all, I'm going to give the first sort of loose definition of the gradient. So the gradient is the slope of the graph. And in other words, just where it sits in the equation, it is just the number in front of the x. This is kind of in the simplest terms possible. So this is the number in front of x in our equation. Now you can try out a couple more examples in your own time. You can get a number line and say try y equals negative 5x or y equals negative a third x. And you can experiment with the type of fractions we looked at. And you can just do it in the same way. You can make a table of values and just plot the points here and draw a line through them. And you can observe for yourself some more cases in which how the negative gradient affects our graph in different ways. I'm just conscious of time here. I want to make this as concise and short as possible. But we've defined our gradient as the slope of the graph, or in other words, just the number in front of the x. Sometimes we call these coefficients. A coefficient is just a number that comes before an algebraic term. But in simple terms, the number in front of the x. And we can say when the gradient is positive, y increases as x increases. We saw this happening in this case, y going up with x, y going up with x, y going up with x going up as well. So that's our first thing that we uncovered in the last video. So when this number in front of the x is positive, then my y will increase with x. We talked about the gradient as telling us how y changes with x. Everything about linear relationships is looking at how these variables change with one another. Now, when the gradient, I'm just going to do these little things here just to write again. When gradient is negative, y decreases as x increases. these are the two main takeaways, the two main ideas from this video and the one before. We spent a lot of time just investigating the role this number plays. And the first role it plays is that it tells us to what extent y increases with x, whether it's y increases by 5 for each x increasing by 1, whether y increases by half for each x increase in 1. We ran through a bunch of examples, and we also now know that the sign of this number, this gradient, whether it's positive or negative, affects it in another way. It tells us whether there is a positive relationship between the two variables, which is as one goes up, the other goes up, or whether we have a negative relationship between these variables, which is as x goes up, y goes down. And this is what I've pretty much summed up here. If there's one thing I want you to take away from this video, it's this idea that the gradient is the slope of the graph, kind of how steep it is, as well as what impact the positive and negative sign, as well as just the general number in front of x tells us. Now, in the next video, I'll talk about the gradient a lot more in depth, and we will look at how to actually calculate this when we're maybe not given it explicitly in an equation here. So I'll see you there.